I think the key for interdisciplinary work, which is almost entirely what we do within bioengineering, is really being interested in the edges of fields or the intersection of different disciplines. So instead of diving the deepest in a particular topic, what is interesting about the merging between mechanical engineering and materials and biology, for example? So some folks are naturally inclined to sort of explore those edges, and others are more engaged to just go super deep on one sort of conventional field. And so I really look for people that want to explore those intersections.
I decided to choose UCSB for my PhD due to its strong hands-on and interdisciplinary focus, its collaborative culture, and the strong network of supportive faculty mentors that are here on campus. My undergraduate research experiences, and in particular some of the hands-on courses that I had, were really formative in my development as a researcher and an engineer, because not only did it introduce me to data analysis and experimental design, but importantly it taught me that I was really interested in applying engineering towards improving human health outcomes, and is one of the reasons today that I conduct research within the interdisciplinary field of mechanobiology.
I think the first thing for me is to understand what do they want to do. What are those goals? I think some people sort of assume everyone wants to work in academia, and that's really not the case. But so trying to understand in particular what do they want to do, and then also recognizing that might change throughout the course of their PhD. So having somewhat frequent check-ins to understand what do they want to do, helping them learn different fields if they're unsure, and then trying to connect them with people in those fields. If it happens to be outside of academia, can I connect them with someone in industry or at the FDA or whatever, such that they can learn more about that, figure out how do you actually enter that field, what are the qualifications you need, how do I set up myself, those sorts of things. And then I think, I guess maybe one other thing on that topic is just telling them that the first job out of their PhD is not necessarily the thing they have to do for the rest of their career, and recognizing that they can choose something that sounds interesting now, and the field may change, they may change, situations may change, but they can explore other options throughout their career.
Something that I've learned from Dr. Ryan Stowers has really been the ability to approach all research problems with a creative mindset and also an open mindset. So whenever we observe interesting results from our experiments, he always pushes me to ask a lot of follow-up questions and really further dive into the why and the mechanism behind some of our experiments. So collectively, I think that is something that I will take forward with me as a future researcher.
Daniella's coming from a mechanical engineering background, and she's doing her PhD in mechanical engineering, but is really interested in exploring biology and in particular how developmental biological processes may be impacted by mechanical properties. She's done a lot of legwork to really get up to speed in biology, and then finding ways to apply her expertise in mechanics. A few things I found really exceptional about Daniella is just the way that she can explore these new areas and really master them, become an expert relatively quickly, and then also honing in or developing her inclination to use analysis techniques, machine learning, AI, kind of pushing the boundaries on what we do as a lab past where we really have established expertise. She's pushing the frontier of our lab forward.